Okay, good morning, grade 8s, or maybe it's the afternoon or the evening, depending when you're watching this. But we are going to be starting the next chapter. So we're starting chapter 8 in your textbooks. You can open up to chapter 8 if you want to follow along. But we're going to go over actually the first two sections right now. And I think we'll go pretty quick. As you can see by my handy title, we are talking about multiplying integers. So if you remember what an integer is, we're looking at whole number units that are either positive or negative. So I have some examples on the board. -2, +3, -3, -4, +4, positive 150, -2,000,000. Those are all integers. So using our positives and negatives. And we're going to look at how we can multiply them together. Now the textbook goes over some ways using integer chips. I am just going to do that very quickly because I think that the rule is very simple and that using integer chips just sort of confuses things. But it sort of explains why the rule works. So let's do it. So let's say we were doing -2 multiplied by +3. Okay, so we're doing this equation right here. How could we demonstrate this? Well, when we talk about multiplying, we're sort of talking about groups. If it was +2 times by +3, we could say, well, we have two groups of 3. In this case, we have -2 groups of 3. Or as a negative, you can sometimes imagine that as taking things away. So we could say this is like taking away two groups of +3. But how could we demonstrate that from starting with nothing? So what we can do is use integer chips, remembering that red is positive. And so let's draw out what two groups of +3 would look like. There'd be 1, 2, 3, 4, 5, 6, right? That's two groups of 3. But let's add in some negative integer chips to make 0 pairs. So blue is negative, red is positive. Thinking of like temperature on the thermostat. And so now on our board we have 0 because just as a quick reminder, our positive integer chip, 1 positive and 1 negative, that adds up to 1 positive, 1 negative equals 0. And so in our diagram down here again, we have 0 in total. So we're starting with nothing. But now we're able to say, okay, well, let's imagine if we took away two groups of +3. So we take this group of +3 away, and we take this group of +3 away. We take them both away, two groups of +3. So -2 groups of +3. What are we left with? All that we're left with is here, which is the answer of -6. Okay? Let's go into our next example. In this case, we have -3 and we're multiplying that by -4. 3 times 4, we can think of 3 groups of 4. But in this case, we have -3 and it's like we're taking away 3 groups of -4. So again, we could use integer chips to demonstrate this. So if we had 3 groups of 4 positives, there'd be 1, 2, 3, 4. That's one group. 1, 2, 3, 4. That's two groups. 1, 2, 3, 4. That's 3 groups of 4. And using our blue as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there's 12 there. And now we are able to remove 3 groups. So since we're removing 3 groups, it's like the -3 groups. We're going to remove 3 groups of -4 this time. So I'm removing 1 group of -4. I'm removing 2 groups of -4. I'm removing 3 groups of -4. So those all disappear. And what do we have left? We have these 12 positives left. So the answer here is +12. When you take away 3 groups of -4, we ended up with a positive answer. Okay, so in our first case, we took away 2 groups of +3. and we got a negative answer, -6. We took away three groups, of -4. Since we're taking away groups of negatives, it's going to make things positive, and we end up with +12. Okay, so this is sort of how you can demonstrate this integer multiplication using integer chips. So you always just start by drawing out as many 0 pairs as you need to get 2 groups of 3 or 3 groups of 4, whatever the question is, and then you take away those whatever groups they're saying. Okay, let's go to the next section. So this, maybe some of you are like, what is going on? Don't worry about it. This integer chips is one way of looking at and understanding it. We're going to go through a rule that will make it fairly simple. So here we have 7 multiplied by 3 in all of its different forms with both integers. So +7 times by +3, -7 times by +3, +7 times by -3, -7 times by -3. So what are the answers to all these? So +7 times by +3, we all hopefully remember that that is equal to 21. And that's positive. And I guess we can write in that positive symbol, even though if it's not there, we assume it's positive. What about if we had -7 times by +3? So we had -7 taking away 7 groups of 3. If we took away 7 groups of 3, we're going to end up with a negative amount. So we end up with -21 when we take away those 7 groups of 3. If we have +7 times by -3, that's sort of like saying we have 7 groups of -3. Well, if we were bringing in 7 groups of -3, we'd have -3 plus -3 plus -3 plus -3 plus -3 plus -3 plus -3. 7 groups of -3 would be -21. And lastly, if we had -7 multiplied by -3, that's like saying we are taking away 7 groups of -3. So since we're taking away those negatives, just like in our previous example here, when we took away the negatives, we were left with just positives. So now here, when we take away those 7 groups of -3, we're left with +21. Okay, so when we look at this, we can see that in every case, the absolute value here is 21. Ignoring positives, negatives, 7 times 3 is always going to be 21. But the different integers will decide whether that 21 is positive or negative. So here's sort of the rule that we can get to. In our first case, a positive multiplied by a positive is equal to a positive. Down here. There. That's just normal multiplication. Second case, a negative multiplied by a positive is equal to negative. In our third case, a positive multiplied by a negative is equal to a negative. And lastly, a negative multiplied by a negative is equal to a positive. Okay, so these are our basic rules right here. Now essentially all we're saying is if you have 2 of the same thing, so if you have 2 positives or if you have 2 negatives and they're being multiplied together, you're going to end up with a positive answer. If you have one and the other, a negative times by a positive or a positive times by a negative, you're going to get a negative answer. Okay, so if you have just one negative, it's going to be negative. If you have 2 negatives, it's going to be positive. If you have 2 positive, it's going to be positive. Okay, those are basic rules. And then you just look at what the numbers are and just multiply them together. So let's do some quick work of this. So here we have -11 times by 4. 11 times by 4, I know, is equal to 44. Is this positive 44 or negative 34? Well, I have 1 negative, 1 positive. That gives me a negative. It's like I took away 11 groups of 4. I have -5 multiplied by -9. 5 times by 9, I know, is 45. Is it positive or negative? I have a negative times by a negative. Two negatives being multiplied together gives me a positive. That's our rule. I have positive 8 times by negative 5. 8 times 5 I can do, which gives me 40. And is this positive or negative? It's 1 negative, 1 positive, so the answer is negative. And lastly, I have positive 3 times by positive 10. Well, 3 times 10 is 30. Positive times by positive is a positive. And there we go. So it's actually really simple. You're just having to do normal multiplication and then use our rule of whether you have 2 negatives or 2 positives or a negative and positive or a positive and negative to figure out whether it is a positive or negative answer. So pretty straightforward. Lastly, what if we had more than one integer being multiplied together? So let's look at what would happen here. Realistically, we would follow BEDMAS rules, which means just going from left to right. And so if we started here with negative 2 times by negative 2, well, negative 2 times by negative 2 is equal to what? Well, that's equal to positive 2, or sorry, positive 4. So a negative times by a negative is a positive. And now that we have the answer of this, that is positive 4, whoa. So that's gone. Now we just have positive 4 here is being multiplied by negative 2. Positive 4 times by negative 2. Well, 4 times by 2 is 8. And since it's a negative and a positive, the answer is negative. So let's erase my scribbles here for a second. I had a negative 2 times negative 2 times negative 2, so 3 negative 2's, and I got a negative 8. That's because essentially my first 2 negative 2's turned into a positive, but then I multiply that positive by another negative, so positive times negative is a negative. So 3 negatives gave me a negative answer. My second problem here, negative 2 times by positive 2. Negative 2 times positive 2 is 4. And is it positive or negative? Negative and a positive gives me a negative. So I have negative 4. I'm now timesing that by negative 2. 2 times 4 is 8. Since it's a negative and a negative, gives me an answer of a positive. So let's look at this now. So this was equal to positive 8. Okay, so I had 3 negatives. I got a negative answer. I had 2 negatives. I got a positive answer. And let's see what happens when I have just 1 negative here. Well, 2 times by 2 is 4, plus 2, positive 2, times by negative 2 is going to be a negative 4, because it's 1 positive, 1 negative. I'm then having to multiply that, bring this positive 2 down, by positive 2. Negative 4 times by positive 2 is 8. It's negative and a positive, so that's negative again, so I have negative 8. Okay, so we look at our answers. 3 negatives gave us a negative answer. 2 negatives gave us a positive answer. 1 negative in our equation, so 1 negative gave us a negative answer. And so the general rule for even equations that are longer than 3 is if there is an even number of negatives, then the answer we can say, well, the product, only if this is only if you're multiplying, not if you're adding or subtracting. So the product, the answer of the multiplication, if there's an even number, the product is going to be positive. So when we initially looked, when there was 2 negatives, a negative times by a negative equals a positive. If you have an even number of negatives, the answer will always be positive. So if you had multiplied 4 negatives together, the answer is going to be positive. If you have an odd number of negatives, so odd numbers, 1, 3, 5, then your product, the answer of your multiplication, is negative. So a negative times by a positive, that's 1 negative. Your answer is negative. Positive times negative is 1 negative. Answer is negative. Positive times negative is only 1 negative. Your answer is negative. Negative times negative times negative up here. Our answer is negative. Negative starts to sound weird when you say it so many times. Negative. Negative. It's weird. Anyways, hopefully that makes sense. There will be an assignment posted on Google Classroom, so you can work on that. Let me know if you have any questions during that scheduled math class time. And have a good week. Talk to you later, grade 8s.